Hello. We're going to talk today about how to simplify square root expressions and solve basic equations with radicals. Okay, so let's go through. So a radical is, you've probably seen the symbol before. The most common radical is a square root. There are others that exist, and we will actually cover others in this course. But for this particular chapter, we're going to stick to the square root. And I want to kind of get you comfortable on how to reduce square root expressions. Okay, so here's the kind of core idea that we're going to be building on today. So if you have a product, so multiplying two things together inside of a radical. Now, if those two things are the same, then we can pull that value outside of the radical. The radical is no longer needed. So I want to kind of put this in practice with numbers. But again, if you have a product of two of the same identical thing under a radical, well, then the radical is not necessarily required. We can just write it as one of those values. Okay. So for instance, all right, so I want you to see this in the action. If I have the square root of 25, you might already know the square root of 25 is 5, okay? But I want to show you the whys, the hows. So I am going to rewrite the square root of 25 as 5 times 5. Now, if you notice, I have a product of two of the same thing, right? It's 5 squared, okay? So the fact that we have 5 squared inside of the radical leads me to believe that anytime I have two of the same identical thing, we can take that and we can pull it out front. That's got to be my answer, okay? Um, so if I do it again, just so, again, practice makes perfect. Sometimes you need to see more than one example. The square root of 49, okay? Well, you may or may not know 49 is 7 times 7, okay? And we have a product of two of the exact same thing. So my answer will just be 7, okay? The radical and the product kind of undo each other. They're inverses of each other. So pretty simple, straight to the point here. I have the square root of 2, and then that little dot here means I'm going to multiply 2. So if I have the square root of 2 times 2, and answer is just 2, right? I have a square root of 2 of the same thing, okay? Again, it's only for multiplication, all right? But we get our answer. Now, let's take a look if we have some different things on the inside, right? So taking that last problem, I put a little times 3. So I want you to see I have a 2 times 2. Change colors here. Times 3. Okay. Now, when I do this, I'm going to split this up into two different radicals. So I'm going to say 2 times 2 is one radical, and then square root of 3. So I broke this apart into two pieces, right? So they're both, every piece is under a radical still. I just broke it into two different sections. Now we know the square root of 2 times 2. Oops, I should have done that in blue. Do that the right way. There we go, 2. And then you can't really break down the square root of 3, so we just leave it as the square root of 3. That's already reduced. So my answer would be 2 times the square root of 3. That would be fully reduced. Okay? I have another one just like it. So if you take a look at this, I'm going to break this up into two groups. I have the square root of 3, and then I have the square root of 5 times 5. Notice I put the two 5s together. Okay? So if we do this, okay, you can't really do anything with the square root of 3. You can't really break that down any further. However, the square root of 5 times 5 is just 5. Now watch how I write my answer here. We don't typically write square root of 3 times 5. The proper way to write it would be 5 square roots of 3. Okay? And that is my answer. I'll keep going. I got more. So I have something like the square root of 63. Now, I don't know what the square root of 63 is off the top of my head. So what I'm going to do is I'm going to kind of break it down, okay? I'm going to break it down into kind of smaller components, all right? So if I do this, 63 I can rewrite as 9 times 7, okay? Again, I want to break it down into a product of two things, all right? Now 9 and 7 are not the same. So I'm going to break it down even further, okay? So when I do this, get my pen working here. I'm going to break 9 down into 3 times 3 times 7, right? And now you can see that I have the square root of 3 times 3 times the square root of 7. Well, whenever I have, right, a square root of two of the same thing, my answer here is just going to be 3. And then there's not a whole lot I can do with the 7. That's still inside the radical because remember, you need 2 of the exact same thing. I don't have that, so the 7 stays on the inside. So the 3 I can reduce to, the 9 I can reduce to 3, but the square root of 7 just stays square root of 7. All right, so I got a bigger number here. But again, my method here is I'm going to take these bigger numbers and I'm going to break them down into smaller values. So I'm going to take this 180. I'm going to break it down. Let's start with 10 times 18, right? That's 180, right? Now there's a lot of ways you can break it down and it won't make a difference as long as we keep breaking it down into its smallest parts. Something called prime factorization. So 10 can be broken down into 2 times 5. 18 can be broken down into 9 times 2. And I think I can break that 9 down even further. So again, don't get lazy with your writing here. I want to write it all out. So I'm going to have a 2 times 5. The 9 can become 3 times 3. Right? Now let's kind of put all of our pieces together. I'm going to put them in order. So I'm going to do that up to the side here. So I'm going to have a 2 times 2 times 3 times 3 times 5. Do you see I put them all kind of in numerical order? I had 2 2s, I had 2 3s, I had a 5. I can break that up now into my 3 radicals, right? So I have the square root of 2 times 2 times the square root of 3 times 3 times the square root of 5. And the square root of 2 times 2 is just 2 times the square root of 3 times 3 is just 3 times the square root of 5 we can't do anything with. So I get, now you can combine the 2 times 3 together. That just gives me 6. And I get my answer. Okay, so break it all down. You're going to get some big numbers. The next example I have is even bigger. Okay, we're going to break it all down into its smallest values. We're going to put them in order. And then we're going to simplify what we can. All right. So I have the square root of 315. So let's break it down, right? So I'm going to take this. Now I'm trying to think of what to break it down into. So I know 5 divides it, so I'm going to use my calculator here. I'm going to say 315 divided by 5 is 63. So I can say that this would be 5 times 63. Okay, I'm going to break it down further. Now the 5 doesn't break down any further. I can't divide 5 by anything. So I'm going to break the 63 down. I think that's just going to be 9 times 7. I think I can break that 9 down a little further. Into 2 3s and a 7. So if I write this in order, I have 2 3s. Notice I keep my multiplication symbols in there. A 5 and a 7. So let's break this apart. The square root of 3 times 3, square root of 5 times the square root of 7. Now, square root of 3 times 3 is just 3. We have the square root of 5. We have the square root of 7. Now, whenever you have two radicals like that, we can always put them back together. That kind of looks funny the way that it's written. So the way that I would really write my answer is I would put these two radicals back together. 5 times 7 is 35. And that is my answer. Okay? I got another one. Practice makes perfect. Okay, we're going to break this all down. All right, so I need to figure out what to break this down into. I have no idea what divides into 252. I know it's even, right? So probably a 2. So 2 times, now if you divide 252 by 2, you get a 126. Okay, if I break that down even further, I don't know what, I'm going to say that divides by 2. So 2 and 64. I keep going. 8, 2 times 2 times, I can break 64 down into 8 times 8. Which then gives me 2 times 2. 8 is 4 times 2. This 8 is 4 times 2. And I could just get a slew of 2's here. See how many 2's I get. All these 4's can be broken down into 2's. So I have 1, 2, 3, 4, 5, 6, 7, 8 2's. So let's write this out nice and neat. 1, 2, 3. Oops, I wrote the 3, not the 2. So 1, 2. I have 3, 4, 5, 6, 7, 8. Right? All under my radical. So I want to break this up into my groups of 2. And I have 4 groups of 2 then. So this is 2, 2. No radical needed, right? Because isn't that the property that we just learned? Now there's nothing left, which is kind of nice. So I can just do 2 times 2 times 2 times 2. So 2 times 2 is 4. Times 2 times 2, right? Then I get 8 times 2, which is 16. I get for my answer. Okay? So again, reducing radical expressions. We just get 16. There's nothing left in the radical, right? We didn't have any oddball numbers. So you can see that this problem doesn't have any values left inside of a radical. It can be everything can be reduced out. Okay. All right. So now I have one with a 6 out front. So I want to show you how to kind of go about this. So we do everything the same. I'm going to try to color code this the best that I can here. Okay, so I'm going to make the 6 blue, and I'm going to make the square root of 50 red. Now I'm going to break down the square root of 50 to 25 times 2, and there's a 6 out front still. Now I can break down the 25 even further into 5 times 5 times 2. Notice the 6 is just kind of along for the ride. There's not a whole lot that we're doing here. Okay, now what I am going to do though is I am going to break up this radical right, into its two pieces. And then I get 6 times, this is just a 5 times, and we can't do anything with that square root of 2, so we're stuck there. So 6 times 5 is 30, square root of 2. So that 6 out front is a little confusing, but did we really do anything with it, right? It was just kind of, you can see it out front here. It's just kind of along for the ride, and then at the very end, I just multiplied. Okay? I think I have another one of those. Yeah. So same idea. Let's try to color code this. So I have a 7 square root of 80. Oh, I should have made that red, right? Let's do that again. Okay, so now I'm going to keep that 7 in front. Let's break down that square root of 80 into smaller pieces. I'm going to say 8 times 10. And then I have a 7 still out front. I think I can break down 8 a little further to 4 times 2. And we can break 10 down into 5 times 2. And I'm pretty sure I can break the 4 down. So let's do that. Let's break it all the way down here. So 4 is 2 times 2. Right? Trying to be nice and neat. I am going to write that in order. So I have 4 2's. And now I'm going to break it apart, right? So I'm going to give myself more room off to the side here. But I have a square root of 2 times square root of 2. A square root of 2 times square root of 2. And then a square root of 5. So I have the 7. This first radical is just a 2. This second radical is just a 2. And then I have square root of 5. So let's put the pieces together. 7 times 2 is 14 times 2. 14 times 2 is 28. And I get my radical. Okay? So that's the idea here, guys. All right? Now, what I want to do is I just want to apply that to some basic square roots, right? Or to some basic equations. So I'm going to kind of go through these steps. Pretty basic. I think a lot of you have seen this before. But if I add 9 to the other side, I get x squared equals 9. Okay. And then to get rid of a squared, all I do is square root both sides. Okay. So when I do this, I get x equals plus or minus 3.